Today we'll be doing problem 35, and when looking at it we're given this image here, right? So it's kind of a lot, right? So our first step would be making a drawing to kind of simplify this, which here decided to make a graph that essentially represents those image, and it kind of like brings everything down together. And so we kind of want to find out in our first step how much work is done per cycle, and we'll come over here, and essentially this is going to be the equation that we're going to be using. Alright, so when calculating our delta P, we ended up getting 2 atmospheric pressure, and when calculating our delta V, it's 50 centimeters cubed. When plugging all this in, one thing to be careful of is essentially like converting your 2 atmospheric pressure and your 50 centimeters cubed in order to get joules, just so everything kind of cancels out efficiently. And from here we're gonna actually move from stages 2 to 3. So from 2 to 3, which is going to be represented also here on this W. And essentially we'll be doing the same thing. The only difference is now that you were taking into account the pressure and volume from 2 to 3. And when calculating that, we get 15.2 joules. Now we kind of need to calculate the engine's thermal efficiency, but in order to do so, we have to calculate first the ratio of temperatures, just in order to kind of progress here. So our ratio of temperatures is going to essentially be this equation here. And when plugging everything and solving for it, we'll end up getting this here. Alright, and from there we can actually start to move on and calculate the engine's thermal efficiency. Okay, so we're going to be using this equation to calculate that here, and then we know that the specific heat at constant volume is going to be this here, and we kind of know this from lecture, right? So we know that N equals PV over RT, and we just figured out what C was. So when plugging everything in, this is what our equation is going to look like. And again, when solving for that and making sure that we convert everything, we're going to get 63.3 joules. So essentially we've calculated everything at this point. We just need the Q here at 3, which is equal to W plus delta U, which is essentially something we already solved for. It's just essentially plugging in at this point. So that was the answer. And now we can calculate the efficiency of the cycle. So here's the equation. And again, this is just a simple plug and chug, which we ended up getting that answer there.